Hello Internet, this is Minjun. I'm working as a full-time SDE. The first series featured in this channel is going to be building a web app. In this series, I'm going to vlog the whole process of building a website for this channel from end to end. It includes design, development, deployment, and maintenance. I like to get criticism from the internet and improve myself as an SDE. I'm going to make the process as close to the real world as possible. Hopefully, this series also can give some beginners an idea on how a simple website is built. This website has a typical client-server architecture. Don't worry if any of the terms do not make sense to you at the moment. They will be explained while we're working on it in later videos. It has several major components: a client web app running on the browser, a server-side web API that this web client interacts with, a database to persist data. CDCI tool will be TeamCity or Jenkins. We will decide which one to use once we need it. In the end of the series, the website will be deployed to AWS for public visit. The source code is hosted on GitHub. Feel free to send pull requests if you'd like to contribute. It's part of the process, so I will probably feature the pull request on the videos. I'm sure it is going to be a very fun journey. Let's talk about some prerequisites. Since most of the time we'll be coding in Java, so please install Java 11 on your operating system. Any text editors will do, but IDEs such as IntelliJ Ultimate, IntelliJ Community, Eclipse, or NetBeans are preferred. The source control system will be using Git, so please install Git on your operating system. This series is for everyone, but knowing if-else and for loop definitely helps. I'll be coding on Ubuntu Linux system, but you can follow the series on Windows or Mac OS with no problem. Alright, here we go. First, let's create a parent folder, SDE Camp, to contain all related subprojects such as our REST API and React.js app. And then we can add a git ignore to ignore unrelated files like IDE specific files or operating system specific files. And then we can add readme.md. It's always a good idea to have this for other people to understand your project better. I already have an existing git ignore that I can use, so that I just copy over to our project. Now let's use git init command to create a git repository under our SDE camp folder. And you should be able to see a hidden .git folder in it. Head over to GitHub and create a SDE camp repository on GitHub. We will map our local Git repository to this GitHub repository. We keep this repository public so that you guys can see it, everybody can see it, and then we don't create readme because I already created in my local machine. In order to be able to push our change to GitHub repository, we need to run these two commands. Before that, we also need to make sure our username and email are set up so that GitHub recognizes us. And when we check out our repository commit history, we should be able to see who commit what. Now it's time to go to GitHub to copy over those two git commands and run that to push our local repository to GitHub. Whoopsie. Let's see, we have a problem here. Let's see what's going on. Let me run that again and see what happens. It looks like we can connect to the repository, but we can't push. Let's try the most useful git command, git status, to see what happens. Alright, this is what happens. We didn't stage and commit our local change so that we cannot push. And it's not a clean status in our repository either. Now let's push our change again. This time it should be working. Alright, let's go to GitHub and see if the change are committed or pushed. Yes, looks like we have our changes. Alright, now it's time to create the Spring Boot REST API project. Let's go to Spring website and generate our project using Spring Boot project initializer. Choose Gradle as our build and dependency management tool. Group is basically a namespace for identifying the artifact. The naming convention is usually reverse domain name plus project name separated by dots. Don't get too stressed about the namings. We're able to change them very easily later if we made mistakes. Artifact is usually a jar file. It kind of represents the final product after the build. Package name is just the base package in our project. We're using Java 11. Add some dependencies to our project. We do not have to add them here. We can add them more later when we need them, and we would absolutely add more. We need Spring Web and Spring Data JPA. Spring Web is for building web-related stuff. Spring Data JPA is an API for working with database. We will discuss in details in later videos. Click Generate. It's going to generate a zip file. Extract and copy the generated project into our SDE-camp parent repository. It generated another .git ignore file. It's fine to keep it. This git ignore has higher precedence than our parent git ignore. It is specific to this REST API project. Delete this unnecessary file. Notice that we have gradle-w and gradle-w.bat files. They are Gradle wrappers. Wrapper is a script that invokes a declared version of Gradle and download the Gradle if necessary. As a result, we can get our Gradle project up and running without installing and setting up the Gradle in our dev system. Gradle-w is for Mac or Linux. Gradle-w.bat is for Windows. It's time to load the project in our IDE. Make sure to open the Web API project instead of our parent project. The IDE I'm using is called IntelliJ IDEA Ultimate. It is only free for students. IntelliJ Community version is free for all. I highly recommend it for Java or Spring project. Because a new project along with its necessary files is added to our parent project, we must commit this change. Stage the change by using add. Commit the change. Push to the origin, which is basically our GitHub repository. Looks like it's pushed successfully. Let's go to GitHub and check it out. Yes, the changes are already pushed. Under the gradle-wrapper directory, we can see a gradle-wrapper.jar file. We don't usually put executable files or jar files in the source control system. However, we put it here so that we don't have to have a local Gradle installed to generate this gradle-wrapper file in order to use wrapper. There's a Stackoverflow thread debating on this. I will include that in the description. Now let's create a sample test endpoint and run the program. Create a test package. Create a test controller with a REST controller annotation. Add a test method with /test get mapping. It means that it will respond to GET request with /test API call. This call returns a string, hello world. Let's run the program with command line. Go to Web API directory. Run gradle-w boot run task. A slight issue comes up. Let's see what happened. Looks like we need to set up database configuration because we added a Spring Data JPA dependency earlier. Let's go ahead and remove this dependency because we don't need a database at this time. Run it again. Now it's running. Let's go to localhost :8080/test on the browser. We should be able to see hello world displayed. Alright, here it is. Ctrl+C terminate the program. If you're using IntelliJ like I am, you can also run this project in the IDE. Add a new configuration. Specify the module to run. Specify the main class, which is Web API application under the base package. Give it a name. Click OK. Now we can run the program in our IDE by clicking the green Run button on the top. Refresh the page. Great, same result. Terminate the program by clicking the red button. In summary, we created sdcamp.com related project. In the next episode, we will talk about Spring Boot JPA database configuration with MySQL. And we'll discuss REST API with Spring REST Doc. Happy coding!